zones here. In my first zone is part one, which is sort of thinking about what the regular price is. So one approach that we can take is brute force, much like what we just did. And so what I'm going to do is, given that I know what the demand is, which is Q equals 6,000 minus 50 times the price, I've got, oh, there's no way you guys can see this. Big. I just built a chart, and the chart is at various increments of the possible prices that I could charge. My variable cost per unit, of course, is $70 no matter what. And so where it really gets, if there's any complication to it, it's that I need to figure out what the demand is. And so the demand is equal to 6,000 minus 50 times the price. So I just multiply whatever price I'm charging times 50, subtract that value from 6,000, and I can figure out what the demand is at every possible price. Then I just subtract the variable cost per unit from the price to figure out what the margin is, and then I multiply the margin times the demand to be able to get the profit. And this is exactly what we did with the cruise just a couple of minutes ago, and now I'm just doing it here with the puzzle, and I find at $95, I can make a profit of $31,250 with a demand of 1,250 units. So that's one solution, is to use this sort of brute force method to come up with a price of $95. So another approach that I might take rather than using brute force is, let's set up a formula for this and let Solver help us. So what I'm going to do is, I know what my cost is always equal to $70. And then my price is a variable amount, so I don't know what that is. Let's say we charge a price of 0. And then I can figure out what demand is. The demand is going to be equal to 6,000 minus 50 times whatever my price is, and that's this cell right here. And so then I could try a bunch of different values. So let's say that I charge $100, right? Then it will tell me my profit is 30,000, and if I charge $110, then my profit is 20,000. And all it's doing is it's solving each one of these little rows on this chart. Or I can set this up here and I can say, well, what would be the price that would maximize my profit? And I can say, Excel, help me out with that. And so I'll say data and solver, and I'll say, here's what I want you to do. What I would like you to do is maximize this profit here. So I'm just going to maximize that cell by changing what? By changing the price. So I'm going to let Excel choose whatever price it wants. And then I'm going to say solve. And Excel comes to a solution and it says $95 is the profit maximizing price. So I can either use brute force, or I can set it up with a formula, which is valuable in order to let Excel do it. Another approach that I can take is, we can do this visually. So here's a graphic representation of exactly what we were doing. So here, you can see that this is the downward sloping demand. As the price goes up, the number of units demanded decreases. At a price of 0, I sell 6,000 units. At a price of $120, I'm not going to sell any units at all. So that's what my demand looks like. And the orange curve has got my profit curve, just like we saw before, that parabolic curve to it. And on the right-hand side is what the profits are. We can see that there's actually a fairly thin margin up here where I can make profit. It's got to be above $70 in order to make any profit, and below 120 where I'm not going to sell any units at all. And then I just find where that spot is, and that's at $95 is where that profit is maximized. And I'll also point out then that you can sort of see, well, at that price of $95, that looks like about 1,250 units is the number of units that I sell. And so this entire purple area, just like we were looking at before, this purple area is my revenue. It's 1,250 units times $95. So that allows me to think about what that total revenue is, which is 87,500. But of that, really only that green area between the $70 and the 95 is what the profit is. That's the amount of money that the firm makes. The rest, the yellow area, I've got to pay my distributor in order to purchase all of those puzzles from the distributor. And so that's another way to do this, is I can just kind of visually knock it out. Or I got a few folks in here who like to use calculus. And so I provided this. I'm not going to require that you know how to do this for an exam, but it's good to at least see that here's what we're doing. Is I got my demand is equal to Q, which is 6,000 minus 50 times the price. So I've got that here. And so the cost per unit then is $70. And so here's where I understand what the profit is. The profit, of course, is going to be the number of units that I sell times the margin that I make on each unit. So the margin that I make on each unit is the price minus the cost. So I've got my price, whatever that's going to be, minus the $70 cost, times the number of units that I sell. That's the 6,000 minus 50 times the price. That's what my profit is. And then all I do is I take the derivative of that profit formula, and from there I set that equal to 0, and it gives me a profit maximizing price of $95, exactly as we would have solved it any of the other 4 different ways that we looked at. So you can see there's a lot of approaches to this. So I've now figured out what the profit maximizing price is, but we'll also point out, let's go back up here, as we now can start to think about part 2, which is what price do we charge if we want to put it on sale. So here we go. Let's just take one more look at this. You can see that this region here, when we sold it at $95, all of these people who would have paid more got surplus. Here's a family here that would have paid $110 and only paid $95 for it, so they're very happy. There's a family here that would have paid $100, they only paid $95, they're kind of happy about it too, so they got surplus. And then there was plenty of people who would have purchased it for between $70 and $95 who did not get to purchase it because it was too expensive for them. And so there's an opportunity to make profit. And the problem is, of course, if I were to lower the price, then all of the profit that I got from the higher price would be lost. And so I don't want to just lower the price. I'm trying to find that profit maximizing price. So instead what I want to do is I'm going to use some kind of a sale price. Here, my blue box is my unrealized profit. So how do I set that sale price? I can go over here. And here's the brute force approach to setting the sale price. Before, let's go back to the beginning, when I used my brute force, what I found was at a price of $95, I sell 1,250 units. So the new demand, if I'm going to set it a sale price, is the 6,000 minus 50 times the price. That's what my demand is going to be at a price of $95, minus the 1,250 people who have already purchased the product. So that's what the new demand is going to be. And so then I can calculate that over here, right? And so what is, at a price of $92.50, what was the demand? The demand at $92.50 was $13.75. But 1,250 of them are already out of the market, so what remains are just 125 people if I were to sell it at $92.50. So all of these folks who would have paid more, they would be happy with it at $92.50, but they've already bought their puzzles, so they don't need another puzzle. And so this is at a price of $92.50. There's 125 people who would say, yeah, I'll buy it at that price. And I can keep figuring out where the profit maximizing price is. And again, I find at $82.50, then I can sell another 625 puzzles and bring in another profit of $7,812.50. So I'm combining the regular price profit and a sale price profit that allows me to make even more money. And the way in which I was able to do that was price discrimination. Those people who are willing to pay more also want a puzzle right now. And so they were willing to pay $95. Those people who are more price sensitive are also the ones that are willing to wait. And so they will buy it on sale after the holiday. And that allows me to extract the profit without the people who would have paid more to run downhill and buy it for the lower price, because if they wanted to do that, they would have to wait until after the holidays to get the deal. And so that's why all of my friends who have any of the Orthodox, Greek Orthodox, Russian Orthodox, who celebrate their Christmas in January rather than in December, I always thought that's so, I don't want to diminish the importance of everybody's religions, but I also recognize there are some that take advantage of the fact that there's better pricing for different holidays. So you get the right holidays, timing, you can get better prices. So as long as your vacation is when everybody else is not on vacation, you can get a better price. So that's another way to look at this. Or I can do this using Solver. So, and this is where it's important to start to think about what is the mechanism that happens here. So here's my original profit just like before. My first demand is equal to 6,000 minus 50 times whatever the price is, and my profit is 31,250. And then the second price, what is the demand? That's equal to the 6,000 minus 50 times the price minus whatever the demand was before. So it's just taking that value and it says that there's 625. So that allows me to figure out what the profit maximizing price would be for the second profit. And so if I didn't have this value already plugged in here, let's say that this price were also $95, then of course the second, if I put it on sale for the exact same price as I had it on before, there's nobody left to buy it at $95. Does everybody see what I've done here? Right? So it's $95 all year long, and they say, hey, it's on sale for $95, and everyone says, I already got it if I'm going to get it at that price. But if I lower the price to $90, there's some people that are willing to buy it. And if I lower it to $92.50, or let's say $85, there's some people that'll buy it. And so I'm just figuring out where the price is that maximizes the profit after that. And I can say Solver, here's what I want you to do. Solver, here we go. Take this cell here, maximize the profit, and do it by changing the second price. Say solve. Right, and it comes to a price of 82 and 50 cents. Make sense? Okay, let me show you one more wrinkle. What I've done effectively is I maximize the profit initially. That's this green box here, $95. Then I found another spot that maximized the profit of the remaining customers in the marketplace at $82.50. Everybody see how I did that? And that allowed me to turn more of this potential profit triangle into green profit for the customer by charging, for the company rather, by charging 2 different prices. But I will point out that potentially there's even more money to be made. If ahead of the season, I said, wait a minute, I already have a plan to charge 2 different prices at 2 different times. What if I start off with a price that's even higher? Why charge $95 and then lower the price? What if I charge an even higher price initially, and then charge an even higher price later on? Essentially move these green boxes over a little bit. Maybe I can extract even more money from the marketplace doing that. What if I did something that looked more like this? So what we did was, we said, what's the one profit maximizing price, and we'll charge that. And then we waited until everything was sold. We did a great job with that. We said, well, now with what's left, let's try to make more money. But what if, long ago, we said, wait a minute, we know that we're gonna charge two different prices. Let's figure out what those two best prices are simultaneously, up front. Can we bring in more money for the firm by doing that? And so what we're gonna do in this last bit is we're gonna allow solver, actually this kind of ruins it, it's already, the solution's already on the page, but right? So here's what we did, regular price 95, sale price 82.50. Now what I'm gonna do is I'm gonna have solver say, simultaneously set these two prices to be able to maximize the profit for the firm. And what I basically want it to do is it's gonna set two prices here, one that's probably higher than $95, one that's less than $95, which will overall come to more money than $39,062. The way I'm gonna do that, again, I could use solvers, so I'll do that, and then I'll show you there's calculus if you like that too. So I'll say solvers, set the objective. What's the objective? The objective is maximize this profit. What are you gonna do? Do it by changing this cell and this. Change those two cells. Say solve. And you can see that if I charge a price of $103.33 initially, I'll sell 833 units, and I'll bring in $27,777. Then when it goes on sale later on, I charge $86.67. I sell another 833 units, and I can bring in a total profit of $41,666.
How did you tell it to use to manipulate two different prices?
Oh, yeah, so I'll show you again, good question, right? So that's just a little bit of Excel magic. I'll go back to $95, and I'll go back to 82.50 where it was, just so you can see, and I'm gonna say solver, and then what I say is solver, maximize the total profit of these two. And how do you do it? I'm just gonna say, you can change the first price, and then comma, you can change the second price. So I just put both of those price cells in the change variables. And let's say solve. And it figures out what are the two prices that will maximize the overall profit. And so I tell a total of 1,666 units, and it's $41,666. And effectively what I've got then is I've got prices here and here, and the total of this green area, of course, is the most that I can possibly get. Which is pretty cool, isn't it? It's kind of neat, right? Okay, and then it's geeky, I know, so not everybody gets as excited as I do about it. And then
at what point though do you stop doing that? 'Cause if you keep doing it, eventually you're just going to match the line, correct?
Yeah, right, so right,
Perfectly.
wouldn't that be great? Right, yeah. So, right, if I do keep doing that, and in fact, in a way, you can sort of think like what happens in these stores. How do they go about doing that? First, I go to Nordstrom's at the beginning of the season, and there's that really, really high price for like the, and then there's the special deal that they have at Nordstrom's for the Nordstrom special customers that only happens twice a year. And then what does Nordstrom's do? They take all the stuff and they put it on special racks in the back of the store. That's yet another price. And then they take all the stuff that remains from that and they bring it to a place called Nordstrom Rack, right, for the more price-sensitive customers, and they sell it at a fourth price. And then that stuff goes on sale and they sell it at a fifth price, so they can take the very same item and charge at least five different prices for the same item that allows them then effectively to be finding customers who are more and more price sensitive to be able to capture more and more of this area. And at its extreme, if we could have complete, and this is coming up with Michael was asking me about this, these, complete methods of dynamic pricing, where we can charge, like the airlines do, different prices for different seats, or different prices, for different consumers. Ideally, that's what, if we're trying to extract as much profit as possible, and that's our only goal, this entire triangle would be green, that would be the maximum that we could possibly do. But obviously, you can see that there's a lot more complexity in order to do this.
Well, it's all derived off the formula. And if the formula's incorrect that you use, then none of this matters, right? For the,
Oh, right, if it turns out the demand curve is not this,
Right.
yeah, well, then we're out of luck, right? Because we're assuming that the demand actually looks like this, that the number of units that we're gonna sell is in fact related to this. And, we can make estimates of that, but we can't always be perfect.
Right.
We don't know that the competition isn't going to make some changes. We don't know that there's gonna be a social, technological, economic, environmental, right? I mean, look at, so for instance, companies may have planned years ago, what the demand is gonna look like based on certain costs. They now know, like, let's say tariffs come into play, this is the problem that a lot of companies are having. The tariffs are an increase in the cost, and we saw what happened in the problem that we just did when we changed the cost, that's gonna change where the profit maximizing price is. So that's a cost problem that I couldn't predict. And maybe consumer demand changes as suddenly people learn, oh my gosh, this particular pharmaceutical that I've been taking all the time might be dangerous to me, particularly, certain times, and I don't want to take that anymore, and that changes people's willingness to pay for the products as well. So all these things can happen. Yeah.
I'm aware of the philosophy. I'm not sure if it's true or false. After observing the pattern for like Nordstrom Rack or Banana Republic, there is a philosophy that people who go to that second-hand store like Nordstrom Rack, they're so used to buying there.
It's not a second, it's right there. It is right. It's
And Dan decides it's
It is
second
discount.
hand.
These companies are actually manufacturing subpar quality clothes directly and putting it there, so that it's not like they're moving this stock. They already identified their customer, the quality of product, like the same product you mentioned, you could make it maybe a not so great model, but a cheaper price, targeting those customers, right?
Right, and that's another thing that we could do, is if the price sensitivity of customers is also differentiable based on certain elements of quality. So the person who's willing to pay more also demands a higher quality product. The person who's more price sensitive is also less sensitive to differences in quality. Then that's another way in which we can engage in price sensitivity and our price discrimination. And that tool is often referred to as a product line sort. I'm gonna offer different versions of my product, and I'm just gonna let customers raise their hand and say, I want the good one and I'll pay more for it. Others will say, I want the one that's more value oriented and I'm only gonna pay less for it. And how do firms go about doing that so that they don't confuse their customers? I'm gonna offer different branded versions of the products.
You see a lot in software sales, like
Absolutely.
products, like, yeah, you get this much storage versus this much storage.
Right,
It's the
even the
same
iPhone, which is
product.
high quality product, I can get the one with a little bit of memory, lots of memory, or a ton of memory in it, or the one with a really good camera, the okay camera, or the reasonably okay camera.
Well, but as you pointed out with the BMW example earlier too, like even Apple found out that was a mistake when they released like the C model, for example, that was the super cheap version.
Yep.
And they realized it was, ruining their brand image a little, tarnishing it to some degree. So much like you're saying for clothing, certain clothing manufacturers, of course, will not do that because they uphold their image differently than something that's more generic, I guess.
That's right, and it's not, they're less concerned, certainly the customers who shop at the Nordstrom Rack are very happy to have access to some Nordstrom products, and it's less likely to damage the equity for those people who shop at Nordstrom, because in reality, the people at Nordstrom Rack end up going out with products that are slightly